Gopinath sir, are you ready?
Yes, sir. Ready, sir.
Fine.
Arun sir, 1 minute.
Sure, ma'am. We'll wait. We
I'm
can
not
have a
able to
testing.
get my video.
Sure, ma'am. I think in Google Meet there will be an issue with respect to playing video. Sometimes it happens.
That's why I'm saying. Okay. 1 minute, sir.
Sure, ma'am. Sure. Ma'am, shall we start?
Arun sir, you can start. I think you can start.
Okay, ma'am. Thank you. It's indeed my great privilege to welcome you all for the ACT STP. It's indeed my privilege to introduce our today's speaker, Dr. S. Venkalakshmi, ma'am. Dr. S. Venkalakshmi currently serves as a professor, computer science and engineering at Sri Krishna College of Engineering and Technology, Coimbatore. She received a doctorate degree in computer science engineering from Manonmaniam Sundarnar University in 2018. She has an experience of around 20 years in teaching and published various journals in peer-reviewed journals. He has also filed several patents and book chapters in her area of interest and also presented papers in international and national conferences. Our research area includes image processing, artificial intelligence, network security, and information retrieval. She is a member of IEEE Computer Society and Computer Society of India. She has organized a number of conferences, workshops, staff development programs, and seminars. She signs in her various responsibilities such as NAC coordinator, NBA coordinator, and entrepreneurship cell coordinator. She was a smart worker who managed time efficiently, examined a problem from all perspectives, and arrived at best solutions. Multidisciplinary approach, the ability to work both independently and in teams, alignment to up-to-date context, and mental alertness, all shown thoughts in our efforts. With our profile, it's indeed my great privilege to welcome you, ma'am, to deliver the talk on machine vision effects in AI and its challenges. Welcome, ma'am. The session is yours.
Thank you, Arun sir. Thank you for the introduction. Good morning to one and all present here. I think you have given a wide introduction. So let us get into the topic directly. Am I audible? Is that clear?
Yeah, ma'am, you are audible. You can proceed, ma'am.
Okay, sir. Thank you. Okay, so the topic here is the machine vision effects in AI and its challenges. So actually, we are going through this FTP, so we'll be learning the basics of machine vision, everything we know basically. So the machine vision, actually, it is a guide to automate the process and the quality improvements. According to the Automated Imaging Association, that is AIEA, the machine vision encompasses all the industrial and non-industrial applications in which a combination of hardware and software. So actually, this was basically it was framed for industrial applications and non-industrial applications too. So it will provide guidance to devices in the execution of their functions based on the capture and processing of images. So what is a machine vision? So how it was formed? And what is the relation with the AI, with the machine vision? So AI's applicability in the machine vision, it relies on affiliated branches like deep learning, machine learning, etc. So what is AI? We know already we know. So AI is a computer ability to simulate the human intelligence. So that is what the machine vision is also doing. Actually, the machine vision is seeing an image through a lens. So that is what a vision is. And this can be programmed and this can be intelligently operated by using a technique. So that is called as a AI. So the AI comes into picture like this. So the machine vision effects in AI and its challenges you are going to see. So AI is a programming, and what is a machine vision requirement is the machine vision requires a computer with an advanced processor, high resolution cameras, and large amount of random access memory. So this can be achieved using a programming. So that programming is our AI. So AI is a programming that is required for depth perception. So basically the machine vision is used in various industrial and medical applications. So what is a machine vision? So the contents which you are going to discuss here is about the definition, components of machine vision, why we are using a machine vision, and examples of the machine vision in AI, and what are the techniques, AI techniques that was involved in this machine vision, and what is its applications, practical applications of machine vision in AI, and what are the challenges we are facing with AI, and what are basic benefits of AI in machine vision, and major goals, and what are the related researches that was happening with the machine vision. So these are the content we are going to discuss today. And starting with just I'll tell you what is a machine vision, and then we'll get into the AI topic. So the machine vision is the process of extracting some information from a visual sensors to enable the machines to make intelligent decision. So the machine has to do an intelligent decision. So that is what the machine vision is. So it's a process of extracting some information to make an intelligent decision. So what are the key points we'll take in this is automated and non-contact. An automated ultrasonic scanner based on the non-contact air-coupled techniques is designed and developed. So you're going to make that intelligent. So that is what the first key point is. Second key point is acquisition. So the image acquisition is a very, very important concept in the machine vision. So image acquisition is creating a representation of the visual characteristics of an object, such as a physical scene or interior structure of the object, characteristics of the object. So that has to be analyzed. So that is what your machine acquisition is. That is also one of the key. And analysis, how the analysis is happening with the images and data. What are all the data which is get processed with the images? So that these are the key points or takeaways with the machine vision. So all together, putting it together, so machine vision will be an image acquisition, integration and applications, analysis. Okay. So image acquisition in the case of lighting, what are the lightings that is used, what are the sensors that is included in the machine vision, and optics we'll get with the image acquisition in that regard, and analysis in the regard of software and the components that is used, what are the algorithms or techniques that is involved in analyzing the images in that regard, and integration and applications. It includes what are the basic applications with machine vision with other techniques, and then what are the communications and automation happening with the real time. So this is what the combined together is your machine vision. So for example, when you see this picture, so one basic thing is that this is an example of the machine vision. So one basic thing was what is the image represents here is consider a fill level inspection system. Okay, so this is a bottle filling inspection system. So each bottle passes through an inspection sensor, which triggers a vision system to flash a strobe light and take a picture of the bottle. Okay, so it is taking a vision system display. So it is taking a picture of the bottle. After acquiring the image and storing it in the memory, so the vision software processes and analyzes that image and issues a pass or fail response. So the pass or fail responses, whether this can be allowed to, because we may be having a limits of filling up the bottle. So a particular ml, it has to be filled. If it is the content is very less, that has not to be passed for packing. So like that it goes. So after acquiring the image and storing it in the memory, so the vision software processes that and it analyzes it and it issues a pass fail response. So that is based on the filling level of the bottle. So if the system detects an improperly filled bottle, then it will be a failure. So that is a cross here. So that is a failure of the bottle. It signals on a diverter to reject the bottle. Okay. An operator can view the rejected bottles and ongoing process statistics on the display. So this is what is happening. So what is this example stays with the machine vision is? So the machine vision can process, can analyze, can measure various characteristics for decision making. So that is what altogether is machine vision. I think this example will clearly understand what is a machine vision is. So it can process, analyze and measure various characteristics for decision making. So that is what the machine vision is. And the strobe that is used here is used to study the behavior of the rotating machinery oscillating vibration of the components. For that, the strobe is used here. So this is what one basic example of machine vision. Okay, when we come to the components of machine vision, components. So components, when you say the lens is a very important component here, sensors, lightings, communication, and vision processing. So these are the major components here. So what is a light source? So the light source used here can be either LED, fluorescent, or halogen lamps. What is a halogen lamps means? It is a tungsten halogen. It is an incandescent lamp that consisting of tungsten filament that is sealed into a compact, transparent envelope that is filled with a mixture of inert gas and a small amount of halogen. It is called as a iodine. So that is what the light source. The components light source can be any one of this, and the lens sensors can be optic and magnetic type, and the vision processing unit. So vision processing unit is an emerging class of microprocessor. It is a specific type of AI accelerator tool. It is designed to accelerate the machine vision tasks. So that is what the vision processing unit is. Then comes the communication unit. So the communication unit, it controls the entire processing pipeline, and it will provide various external interfaces such as USB, firewall, Ethernet, etc. So that is what the communication unit is. These comes as a components of a machine vision. Okay. So why do we need that vision, machine vision? Why do we need that? First thing, dynamic range. So for a quantitative calculation of a image or amount of data, ratio between the largest and the smallest values, that a certain quantity can be assumed. So for that reason, we need the vision. Secondly, when a thing is long away from the people, or some long away from the places, so it cannot be easily identified. So for that case, it can be remotely situated. So for that case, the images of the objects, if it is remotely situated, we need some vision on that. So that is the second thing. Third, passive. So passive here, when the objects doesn't emits any energy, like laser or IR, or if it doesn't emits any energy or no contact is required, we can make. That is why we are using the machine vision. And passive, it just listens to what is going on with all the machines connected to the system. So that is why we are using a passive. Okay, we need a machine vision on that. Flexibility, affordable. So it should be of affordable cost, and it can be moderate or it can be flexible with the usage. So for that reason, we are using machine vision. So why do we avoid machine vision? As of seeing the pictures in the first three images, when a human identifies that images, in their perception, the variations in illuminations of the images are identified easily. But when it is given to a machine, so it cannot be easily identified with the illuminations and recognize all the three images are same. So by looking at it, the human can look at the images and he can identify that all the three images are same. But a machine cannot identify easily. It needs some parameters to verify the changes in the images. Okay. So in that way, computation, calibration, and sensitivity to lighting conditions. So these three conditions are necessary to differentiate between the images. So calibration in the sense setting a correcting of a measuring device, usually by adjusting it to a match to unvarying measure. So we are correcting a measuring device, and that can be adjusted to an unvarying measure. So for that reason, we are using a calibration. Computation, the images has to be processed and the information has to be collected. So this is for the second thing. And the third one is sensitivity to lighting conditions. So the lighting conditions is very important. What is specific lighting that is used in this vision? So that machine vision, that we'll learn in detail in the upcoming slides. So lighting is very important thing in the machine vision. So sensitivity to lighting conditions is one important issue for the machine perception to identify an image. So that is one important thing. So this is why we don't avoid visions. And An example application is a micro manipulation here. So the micro objects can be easily handled with the micro gripper. So this is what the image represented here. Micro gripper can easily identify the micro objects easily. So that is what one example of the machine vision. And altogether, so what is a machine vision? What are the elements involved in the machine vision system? So a machine system involves image acquisition. So it is generally a camera that is placed in the production, and image pre-processing. So pre-processing, as you know, so increasing the contrast, motion, and the etc. Feature extraction, extracting the features of a particular image, and checking out the distance between the two objects, and then decisions whether that is kept in the correct positions or not. So that is tolerated to a particular vision of the image. So that has to be identified. That is by decision. Control, that gives a result to a programmable logical controller, or it can be a robot controller. So that will control the entire processing unit. So these are all the important elements that is used in the machine vision. And image acquisition. Getting into detail of image acquisition and then lighting. Before getting into that, we'll see what is we'll have a video on what is image machine vision is and why it is used for processing.
What is machine vision? To start, let's talk for a second about our vision, human vision. For the purpose of this conversation, let's break down what we see with our eyes into two basic categories. One category contains objects, visuals, or graphics that were designed by humans to be looked at and to communicate specific information to other humans. This can be anything from a simple graphic or symbol to the complexities of a fine art painting through to the sophisticated alphanumeric systems that man has created and perfected to communicate our most complicated thoughts and ideas. We have developed a vast array of visual forms and systems for the purpose of this kind of communication. The other category is just about everything else we look at that is part of our world and universe. But this is also all about communication. When we look at anything, consciously or unconsciously, we analyze what we are looking at. Does it look warm out today? How many people ahead of me in line? Do I see much traffic? Does that apple look ripe? Machine vision can also be broken down into two almost identical categories. The first is visual systems that are specially designed for analysis by machines, or more specifically, some type of computer or smart camera system. This would include barcodes, specialized symbol systems, or optical character recognition fonts such as OCR, A, and B. The purpose of these machine-specific systems is the same as the human version, to be able to very quickly, very accurately communicate particular data or information to the intended audience, in this case, a machine. Enabling machines to visually analyze other parts and pieces of the world is where the most creative and sophisticated forms of machine vision engineering are being developed, and JADAC is an industry leader in this engineering science. At its core, engineering is the act of observation. When a piece of visual data is required, the engineering process breaks down the visual event to the processes involved, and then it identifies mechanical and analytical processes that can be used to recreate it. These identified processes become the machine vision function modules, which when combined and executed in specific order, result in the acquisition of the desired data. Leveraging many years of machine vision experience in the healthcare field, JADAC has developed a medical machine vision toolbox called Clarity, with a simple and intuitive graphical user interface. Clarity controls basic machine vision function modules using JADAC smart cameras. Clarity's machine vision modules include Count. As the name implies, identically shaped objects or blobs are identified and counted. Pattern Match. Searches for a match in terms of brightness, contrast, size and shape with regards to pixel location and levels, or searches for an exact match defined by an edge of a shape. Presence Absence. Detects a presence or absence of a feature in an image by looking at the pixel thresholds, average brightness values, or high contrast edge pixels within the set ROI. Decode. 1D or 2D barcode, you can use this plugin to decode these barcodes. Finder. The Finder plugin can be used to search for vertical lines, corners, and circles in an image. Measure. The function of this plugin is to measure the distance in pixels between two previous modules. Color Detection. Acquired color images allow the color detection module to specifically identify targeted colors within that image. If you would like more information on Clarity or JADEC's capabilities,
machine vision technology. Welcome to Microscan's Introduction to Machine Vision, an educational webinar series to help new users better understand the basics of machine vision technology. This is the second installment in our series, and in this presentation, we're going to cover the why of machine vision. What benefits can it bring to the factory floor? I'm going to talk about 4 ways that machine vision can help manufacturers save money, and why this automated process is better suited to repetitive inspection tasks than human inspectors. If you tuned into our previous presentation, then you already know what machine vision is and its 4 most common applications: measurement, counting, location, and decoding. You might use these tools to achieve a number of different ends, but the motivation for doing so is generally like all others when you're applying industrial processes: to save money and increase profitability. Thinking in these terms, machine vision accomplishes this in several ways: by reducing defects, increasing yield, tracking parts and products, and facilitating compliance with regulations. Machine vision inspection can reduce defects or cause what we'll call fewer catastrophes. Fewer bad parts getting out into the world and into customers' hands, which could damage a company's reputation and lead to costly product recalls. Along those lines is preventing mislabeled products, parts where the label doesn't match the content. Mislabeled products create unhappy customers and have a negative impact on a company's brand. They may even pose a safety risk. Consider the consequences of improperly labeled pharmaceutical products or mislabeled food items for customers with allergies. This is a very common reason for product recalls. Machine vision can verify contents and ensure that products are labeled properly. Here's the label matching application we showed you in our last presentation, where we use machine vision to read the 3-letter text or OCR code on the top of a vegetable can to match it to the correct label. Another incentive for machine vision is better yield. Simply the ability to turn more of the input material into saleable end product. If you catch defects early in the production process, you'll reduce waste, because bad parts can be identified and eliminated before they're built into larger assemblies. You'll avoid scrapping expensive materials and reworking parts. This image shows a molded lead frame, an electronic part that our vision system is measuring to detect any deformation. By detecting defects at this stage, we'll avoid having to scrap larger assemblies later on in the process. Machine vision helps to reduce downtime, another benefit that falls under this category. For example, a packaging line may use a vision system to detect product misfeeds that could cause the machine to jam and result in downtime and loss of product. In the case you see here, a vision system is ensuring that these baked goods are properly aligned as they travel down a conveyor. Items that are out of tolerance will be expelled from the line before they can cause a system jam. I'm sure you're aware of the usefulness of tracking work in process, or WIP, uniquely identifying products so that they can be tracked and traced throughout the manufacturing and stocking process. Machine vision can be very helpful here. Typically, if you can identify all of the pieces in a process, you'll require less stock, and product becomes available more readily for just-in-time processes. Machine vision uses decode tools to read 1D and 2D symbologies, as well as OCR to track parts and products. This helps manufacturers to avoid component shortages, reduce inventory, and shorten delivery time. This is also where the Auto ID Plus aspect of machine vision can be beneficial. Of course, track and trace applications such as this are commonly accomplished with dedicated barcode readers or imagers. Machine vision provides the added benefit of being able to perform other tasks, such as alignment or measurement, in addition to reading barcodes and OCR. As an example, you may want to read a data matrix code on a PCB, and also verify its location on the board. Complying with industry regulations is often an unavoidable cost, but if you don't comply with the regulations relating to a particular product, you may not be able to take part in that market. Being able to do so efficiently and at low cost is clearly beneficial. The pharmaceutical industry was an early adopter of machine vision for this reason. It is, of course, a highly regulated industry and requires strict adherence to government regulations to ensure product integrity and safety. A common application we see here is the verification of lot, date, data matrix, and other code formats, a requirement for compliance with standards such as 21 CFR Part 11 and GS1 data standards. Unlike a dedicated barcode reader, a vision system has the capability to not only read the codes, but to verify that the labels are printed accurately and legibly, ensuring that they are readable later in the supply chain. There's also the broader question of, why use automatic systems like machine vision to do things that you could potentially do with human inspectors? The answer is, quite simply, machine vision systems never get tired. They excel at repetitive tasks. Once they're set up to do an inspection, they will do it all day, every day. Whereas with human inspectors, you would typically expect to find an error rate going up after about 20 minutes on a particular task. Machines do it faster. You can inspect things more quickly with a machine. The other great benefit is consistency. Once the rule is set, it's set and will stay set. People who are inspecting or operating a process have a tendency to change the rules as they go along. So that should give you some pretty clear justification for using machine vision. Let's review. Machine vision helps manufacturers increase their profitability by reducing defects, increasing yield, tracking parts and products, and facilitating compliance with regulations. We also compared the benefits of machine vision to human inspectors. Machines are faster, more consistent, and can run for longer periods of time. With so many compelling reasons to incorporate machine vision, you're probably ready to learn what
Okay, I think now you are very clear about what is machine vision and what are the benefits or why we are using the machine vision. So that was very clear. Okay, so the one important thing here with the elements is image acquisition. So that was the important thing. So image acquisition actually transforms the visual image of a physical objects into a digitalized data. So illumination, it deliberate the use of light to achieve a practical or artistic effects. We are using some sensors. So sensory sensor or sensitivity. So that is, it's a ratio between the output signal and measured property. So most sensors have a linear transfer function. So by using the sensors, and the image is detected, and it is formatting the output signal related to that. So these are the image acquisition, that is illumination, image formation, detection are using a sensors, and formatting the camera output signal. So converting or transforming a physical objects into a digitized data. So image formation detection. So the image is actually formed by illumination, cell lens, or photosensitive detectors. And the vision system have a optical electro devices that converts the electromagnetic radiation into an electrical signal. So that is what with the help of image formation is. So the vision is a very important thing here. So it can vary with the shape, lighting, relative positions, and sensors. So with that, the same image can be seen in a different images. Same shape of the image can be seen in different shadows, different lightings. So how this can be identified by a computer machine or a machine or a system. So that is what we are going to learn. What are the different types of lighting available? Because lighting is a very important concept in the machine vision. So what are the different types of lighting means? First one is a structured lighting. So structured lighting is actually the process of projecting a known pattern into a scene. So it calculates the depth and surface information of objects into the scene. So that is what the structured lighting is. And the second one is directional backlighting. So it is an actually multiple view display and multi-direction display. So that is what the second lighting is, directional backlighting. Third one is diffuse backlighting. So it is scattered by particles. So it appears to come from all the directions. So that is what the diffuse lighting is, backlighting. Fiber optic LED ring lights is using a optical fiber as a light pipe. It transmits the lights from a source through the fiber to a remote location. So that is what the fiber optic LED ring lights. Polarized light. Polarized lighting can be produced from the common physical process that deviate the light beams, including absorption, refraction, reflection, etc. So that is polarized lighting. Direct front lighting. So this is another type. So it is the lighting that emanates either from the behind the camera or from the camera itself. So that is what the direct front lighting. Oblique lighting. So oblique lighting, it uses a light source positioned at a low angle. It creates a shadows on the surface of the evidence. So that is what the oblique lighting is. Cross polarization. So it's an orthogonal to the polarization. It measures how much leakage has happened between the two polarization in a given antenna. So that is what the cross polarization is. And other types of diffuse front lighting, it is not harsh and direct lighting. So it was a softened lighting in the same way. Okay, so that is what the diffuse front lighting. Dark field illumination. So dark field illumination is reflected away from the camera. So the reflection that happens away from the camera is a dark field illumination. Fiber optic near lighting is safest lighting method for pools and foundations, etc. So these are the different types of lighting that was used in the machine vision concepts. And next is the image formation detection. So as all we know, so the from the basic light sites, the objects can be captured by using a lenses, and CCD sensors is a complex electronic component that consists of a multiple arrays of light-sensitive semiconductor elements that capture the objects and that converts that into a digitalized output. So this is what the formation detection of a image. And digitalization of a camera signal or analog image data is sampled and quantized into a grayscale image file. So that is what the digitalization of a camera signal. And the software used in this. So software is processing the data. So the software allows the image to be processed, analyzed, and stored. So actually the machine vision work are the aim of that is to process the image, analyze the image, and measure the image. and that is what is happening with the help of a software. So the software allows the image to be processed, analyzed, and be stored. So there are different types of packages available, and the software development kits and predefined tools. It allows the programmers to customize the image applications, and one such tool which you are using is a MATLAB. So that will help to process the image, analyze the image, and storing the image. And image pre-processing and feature extraction is also a part of processing the data. So pre-processing, as all we know, so it is to process the image. So it needs to pre-process the image in order to analyze it. So it removes the motion blur and enhance the contrast of the images. So for that we are using pre-processor and feature extraction. So analysis has to be done with the 1D vision, 2D vision, and 3D vision. So, for example, if 2D geometric analysis is happening, means it must have a high contrast to the segments from the background. That is backlighting. So many lightings we have seen. So, in practice to the backlighting, so how come the segments or the objects has to be projected? So that has to be concentrated on that part. And the silhouette. So that's a dark solid shape of something that is seen against the light background. So that is this. This has to be determined. Part dimensions with the help of the width, height, orientation, and the part features. Number of, if you are saying as an example of bottles, identifying whether the bottle is filled or not, so we can check with the number of holes. If there are 6 holes to be identified, and if all the 6 holes are blank, that is, it is empty, it means that the bottle was already filled. If any of the holes have some blocks, then it may identify that there is some problem with the filling up of a bottle. So that has to be rectified. So part features, with the features that can be easily identified, and relationship between the parts. Okay, so with that also we can identify the extraction or analyze the features. And one scenario is that if we can see, why can't the computer? So that can also see and it can able to analyze the things. So that will minimize possible problems. So the human eye and the brain are elaborated and they can identify the objects very easily, because we know if there is 2 identical persons, we can differentiate them by their clothes or some features with their humans. But this cannot happen with the machine. So we have to train the machine. So it can happen it can only perform when it has been programmed to perform. So we have to make that train. So that training is happening with the help of the programming techniques. So common variables include objects colors, surrounding lights, camera focus, and improperly mounted cameras, environmental vibrations. These are the features that is commonly available variables in case of machine vision. So we are learning about machine vision, so we are concentrating on that. So these are the common variables available. So with these variables, how come the machine can be trained to learn the environment? So when we see an image, so if we want to find the man in the particular image, so the visual tasks for this finding out a man will be very difficult. For even a human cannot identify that hidden image in the image that was given here. But how come a machine can do that? So it has to be trained. So the national systems like advantages of taking visual tasks in disasters. So some different pictures. So different pictures are same pictures with the different scenarios, different angles, and different lightings. So how that can be identified? This all has to be trained. So we have to train. This is the one caption. Knowing what the system can and cannot see are the important points. So that we have to obtain the results and reduce the errors and incorrect measurements. So what we have to do is we have to train the machines. So that is what we are engineering the environment. So engineering the environment concerns with practicing or protecting, concerns itself with protecting people from affecting from the negative environmental effects. So from the negative environmental effects, you have to train your system with the environment. So that is what a machine has to do. So this is also one aspect of training the machine. So that is what the machine vision role is. So controlling the environment will be easy to segment an image. Like, so you can with the help of the measurements from different images, like training the images with the visions, different types of visions, and the relationship between the images and the pixels and the actual images. With that, you can train the images. So that can also possible with the measurements from the images. And so far, what we have seen is with the machine vision. So now we'll get into the topic of the combination of two. So machine vision in AI. So actually, what we know, what is machine vision, why we are using it, everything we know right now. So your machine vision is an ability of a computer to see an image. It can employ video cameras. It can convert analog to digital signals, and it can process digital signals. So these are the roles of a machine vision. So altogether, it resulting data goes to a computer or it goes to a controller of a machine. So that is called as a robot controller. So the machine vision is similar in complexity to voice recognition. So what is the role of AI in this? So there are some common AI techniques. So that helps the machine vision work. How we are going to relate the machine vision with AI techniques. So we'll see one by one. So first we'll see the techniques of AI, then how this is related with the machine vision, then we'll see. Artificial intelligence, it involves the development of computer programs that mimics some of the natural intelligence. So common techniques that was used here are expert systems, fuzzy logic, inductive learning, neural networks, genetic algorithms, and swarm intelligence. These are some of the common techniques. How these common techniques are used in machine vision to train the images. So that is what we are going to see. Expert system. So first we'll see about expert system. The expert system actually is a program that uses AI technologies to simulate the judgment and behavior of a human or an organization that has an expert knowledge and experience in a particular field. So that is what an expert system is. So if you want some advice on some of the topics, or if you want some any information related to a topic, so that can be given to a expert, and we'll be getting an opinion about that from the experts. So we are training the machine to get an opinion about that experts. So the programs would have embody the knowledge about a narrow domain for solving a problem. So MySyn is one of the app that has been used for medical diagnosis. It just acts as a doctor that diagnoses patients' health problems. So that is one of the medical app. So that was used for medical diagnosis. That is one example of expert system. And the two main elements concentrated here is a knowledge base and the method for reasoning about the knowledge it contains. So this is the first technique, expert system. Second is a fuzzy logic. So when you say about the fuzzy logic, it's a form of many valued logic in which all the true values of variables may be any real number. So a real number between 0 and 1, the booleans of 0 and 1. So that will be the basics of fuzzy logic. So it reflects a qualitative nature of a human reasoning, and it will identify whether either one true or false. So that is what the fuzzy logic is. For example, the word heart, that instead of absolute temperature value like 0 and 1, this can be taken as very much. You can see the picture here. So very much, little, and the very least. So 0.9 is taken as very much, and 0.025 can be taken as very little, and very less will be taken as 0.1. So like that it will be categorized instead of having that as a general of 0 and 1. Boolean logic, it can be taken as a fuzzy logic. So this is the basic example. So fuzzy logic can be expressed in the quantitative statements or fuzzy rules. For example, one basic application, famous application in the washing machine is to detect the load size, fuzzy logic is used. So that is one example in the fuzzy logic. Then comes the next technique, inductive learning. So what is inductive learning? So inductive learning is it is known as a discovery learning. It process where the learners discover the rules by observing examples. So they'll observe the examples. With that examples, they'll be discovering the rules. So that is what the inductive learning is. So in the diagram, the right hand side that represents inductive learning. So it represents a behavior of an image, and from that behavior, the rules will be formed. So that is what the inductive learning is. So the opposite to that is a deductive learning. So it is a part of the machine learning. It uses a mathematical analysis of a given data set to generate its knowledge. So that is what the inductive learning is. So example is in ID3, it creates a decision tree from a data set by calculating the entropy values for each of the attributes in the data set and determines which attributes and which attribute values can be most efficiently used in the out of the entire classes. So that can be identified by using the inductive learning. So by analyzing a particular process, that is analyzing a particular image, so that rules can be framed on that. That is inductive learning. Next comes, you all know that is neural networks. So the basic technique is a neural network. So it is a computational model of the brain and that have the learning ability and it is mainly, it can learn the domain knowledge from some examples. So it consists of a series of algorithms that endeavor to recognize the underlying relationships in a set of data through process that mimic the way of the human brain operates. How the human brain operates, neural networks work on that. So a neural network can provide enormous answers to the problems, even though they cannot provide an explanation. So if they cannot provide an explanation, they can provide some answers to the questions that was asked. That is what because it was trained to provide some answers to the questions. So like that, the machines will be working on. So it may not provide the explanation, it may be trained to give an answer to the questions. So the neural network models are usually assume that the computation is distributed and several over a simple units that is called as neurons that are all interconnected and that operates in a parallel. And very popular neural network is a multi-layer perceptron. So that consists of neurons that is arranged in a series of layers. So that is one technique. The next technique is a genetic algorithm. So genetic algorithm, just I'm saying what is what because we have to relate your machine vision with the AI technique with some examples. So for that, we have to know about the basics of the techniques alone. So that is why we are not going depth into the techniques. Just we will say what is the techniques. What are all the techniques available with the AI? So genetic algorithms. So genetic algorithms is actually a search heuristic process. That process of natural selection that belongs to a larger class of evolutionary algorithms. It solves both the constrained and unconstrained optimization problems based on the natural selection process that mimics a biological evolution. So that is why we are going for a very large different search space. One basic example is a traveling salesman problem. So in traveling salesman problem, given a list of cities and distances between each pair of cities, what is the shortest possible route that visits each city exactly once and returns to the original city. So this is what the traveling salesman problem is. And optimization of this problem and the solution to that traveling salesman problem, as we know, NP hardness problem. So the NP hardness and the optimization of this problem can happen with the genetic algorithm. So that is what one example of the genetic algorithm. So it is based on the theory of natural selection and where the fittest animals survive and reproduce. So this is what the genetic algorithm is. Then comes the swarm intelligence. So the swarm intelligence, it's a collective behavior of the decentralized, self-organized system. So it's a natural or artificial. It is used for developing computer algorithms and motion control, and it's a principles for robotics. And as all we know, so how the ants work together in a colony, creating a system that is a greater part of the swarm intelligence. So likewise, the mimicking the behavior of the ants. Here also, sex are to produce a smart solutions to problems. So that is what is our smart intelligence here. And so these are the what we have seen so far is the techniques, AI basic AI techniques. How come this AI techniques are used in the machine vision? Techniques in the machine vision. So practical applications, how these techniques are used. So that is what you are going to see now. So the practical applications of artificial intelligence and machine vision. So we are going to see about the Pulnix Zycam, Smart Search, NeuroCheck, Cytic iPod, and ILIB software. So these are the practical applications of those artificial intelligence techniques in machine vision. So the first technique is first application is Pulnix Zycam. Actually, this is a smart camera. So the picture shows it. It's a smart camera. It does not need a programming. So it is presented good and the bad parts. So it learns how to differentiate them using a hardware neural network. So the Zycam that contains a engine, recognition engine, that extracts the 64 features, including the histogram, profiles, and pixel samples. So these features are passed to the neural network, which has 74 outputs. So instead of just have a pass or fail output, it will be trained to separate the products into 74 classes. So that is what the major application of this Pulnix Zycam. So it's a smart camera. Instead of directly extracting the features, usually it will separate either it is pass or fail. So that is a machine vision with the camera. But instead of not doing that, it is trained to separate the products into 74 classes. So that is what the feature extraction is happening with the neural networks here. So this is one application. Second application is a smart search. Smart searching. Usual search with the Google search engine, that is with any of the search engines, we'll be doing a normal search. But here, smart search is an adaptive pattern locating software. This is a software. This was provided by Carico Imaging. So as a part of the Sherlock and the machine vision tools vision packages, they have provided this particular smart search. What is the role of that smart searches? It contains a training wizard that is based on the artificial intelligence to facilitate system setup. So the developer need only to provide a good and the bad examples of the object. It will smart search learns the characteristics of the object automatically. So we can provide some examples of the object, either good or bad examples of the object alone can be given to the system, and it will train the machine by learning the characteristics of the object automatically. So that is what the smart search is. So this is second application. And the third application is NeuroCheck Compact. So NeuroCheck Compact is also a smart camera that can be programmed using a mouse. It can be programmed using a mouse. So the system contains a NeuroCheck package that is able to compute number of object features from the regions of interest in the images. So these features are then passed to a classification module which determines the type of region being inspected. So which was the particular region that was inspected, that can be identified by using the classification modules. So this is also a smart camera in identifying the object features. So that is NeuroCheck Compact. And then next application is Cytic iBot. So usually the iBot is the name of a robot family that is developed by a UWA. And this Cytic iBot, it leans a art form and features. It uses a combination of two techniques, that is fuzzy logic and the neural networks, known as the NeuroRAM, combining two techniques, fuzzy logic and the neural networks. So the iBot is available in two formats. One is a shape iBot, and one is spectrum iBot. So shape iBot, it recognizes the shape of the objects that are placed in front of the camera and detects any images with the deviations from the learned shape. And the second one is a spectrum iBot that learns the color of the objects that are shown to it. So the output of the system can be the integer from 0 to 99 that indicates the status of the product. So that is what the second type, that is the second form of spectrum iBot. So the iBot represents features of the image with a combination of two techniques, that is fuzzy logic and neural networks. And comes the important thing, that is the software. ILIB software. Okay. So that is an intelligent library management software. Intelligent library management software. This is that. So the library for managing the books, images, etc. So managing some techniques and incorporating many artificial intelligence techniques into that software. So it contains some pattern recognition, statistical, fuzzy logic, neural network tools, everything is there with the software. So neural network functionality of ILIB is provided by a very special, particular, popular neural network, that is multi-layer perceptron neural network with many configurable parameters like learning rate, momentum, number of neurons, number of layers, and the activation functions. So it contains a pattern recognition techniques such as minimum distance, finding out the minimum distance, and the nearest neighbor classification. So these are all can be done with the ILB. And also the feature vectors can be analyzed by using a software, ANOVA. So ANOVA is an analysis of variance software. ANOVA is an analysis of variance software. It's a collection of statistical models and their associated estimation procedures that is used to analyze the different difference among the group in a, that means in a sample. A sample of image can be identified in a group. So that is with the help of the ANOVA software, analysis of statistical models. So that is that software. So that software, it incorporates fuzzy logic classification functions and genetic imaging. And the genetic imaging, it provides a system with the original image and the image that is desired from the image processing techniques. So there is some convolution filters required to convert the original image into the target image. So this is what the help of this software, and the software will be like this. So you can search field with author, title, and the subject, and the search expressions can be given. So with the formats that can be given, and you can search the results with this. So this is an advanced search or the search library, intelligent library management software that will identify and manage the books and images or by using any artificial intelligence techniques. You can make use of this software. So far what we have studied is discussed is some techniques, and then with the techniques, what are some practical applications? After that, so we have clear with the applications. So then, what are the challenges with the machine vision in AI? So what are the basic challenges? First one is random object picking. That will be a biggest problem. Second one, random box depalletizing. So when depalletizing is boundaries between the boxes are very difficult to judge with the intelligent vision systems. So boundaries between the boxes are very difficult to judge with the intelligent machine vision systems, and the work pieces may also vary, and there will not be a particular match with the schema systems, and the clever robot has to identify with the boxes. So that will be a problem. Second is a defect and flaw detection. So finding out a defect will also be a challenge always. Detecting a defect and the flaw, detecting defects, and then dynamically the system will get changed. So this will be a biggest challenge. And camera mobility in the vision system. Moving a camera to inspect different locations on larger part or beyond the robot's reach. So that will also be a problem. Then imaging inspection involving glossy, reflective, and shiny metal parts. Inspecting the glossy, reflective, and shiny metal parts will be a little tough when you are comparing with the normal objects. Then high-speed inspection. Any machine vision system that must run at rates of above 30 FPS is considered as a high speed. So depending on the size of the product, the speeds may vary from 30 to 50 FPS. So that can be incredible. So that will be a problem. Then the vision guided robots. The collective term of the machine vision and the image processing systems is used to form positioning, detection, inspection with the industrial robots. So accurate movement to variable target position is a very difficult. Finding out an accurate movement to variable target positioning is very difficult. So that is vision guided robots. And multispectral imaging. Multispectral or hyperspectral imaging is it captures the image data within a specific wavelength, ranges across some electromagnetic spectrum. And capturing the image data with a specific wavelength range will be a difficult task always. Then polarization. So the property applying to transfer waves that specific geometrical orientation of the oscillations will be a biggest problem. The property is applying a transverse waves, but that will be a problem in specifying a geometrical orientation of the oscillations always. Embedded vision. So integration of a camera and processing board. So that is embedding vision. So the vision system consists of a camera and PC, and both are large and expensive. So that will also be a biggest challenge. So these are all the challenges with the AI in machine vision. And challenges with regard to the building information modeling, a specific structural challenge. When we say structural challenge, that is building information modeling. When we say with regard to the information modeling, that is building information modeling is a revolutionary construction industry. It is available for bridges and tunnels. It is not suited for built and as damaged information mapping. So that will not be suitable for that. So that will be a problem. Reconstruction and with regard to the recognition, the performance of the machine vision with related to the environmental factors such as lighting conditions, illumination changes, viewport distancing, camera movements outdoors. So this will be a difficult thing. And one upcoming thing that was to overcome these challenges is the unmanned aerial vehicles. Unmanned vehicles, that is self-driving cars. So that is one upcoming challenge. So that is emerging now. So it will cover the entire facility of the problems that faced with the machine vision. And then damage in case of damage detection and assessment. The automated damage properties retrieval to perform a structural integrity assessment has not yet achieved. So that is a problem. Any damage causes to a particular retrieval process, then it cannot be rectified easily. So integrity with the structure will be a problem here. So these are the challenges with the machine vision. And one important challenge with the machine vision and with the combination of AI. So machine vision with AI, that particular combination of techniques that solves the social and beneficial cost, and it's the overcomes the challenges of the business. So solving some of the toughest social and beneficial challenges was happened with the machine vision and AI. So this was one of the important article in 2018 by Intel IT peer network. So what was the article that was mentioning is it combines artificial intelligence technique and the machine vision technique. It solves the problems of business and the social challenges. The human visual perception is a very important thing. The humans have limited capacity to evaluate and they compare a detailed visual tasks at once. And the combination of different technologies with different applications, it's a challenging role. So how this particular AI and machine vision overcomes that challenge. So what the challenge that was represented there in the article is how the machine vision can solve one of the society's biggest challenge. What was the society's one biggest challenge was missing of children. So missing of children nowadays it was quite less, but anyway that was happening still. So the new images of the children, so missing of children and some database can be maintained to map up the children with the miss out children. This can be happened by using a software. and a trained algorithm can be used for that. And what was the biggest challenge that solved by this machine vision is here explained. So new images of the children from the identified content are taken and that is analyzed with the features. And the features vectors are calculated and they are extracted. One thing. There. So many algorithms in the machine learning, it require a numerical representation of objects to facilitate the processing and the statistical analysis of images. So we are training an AI algorithm that compares the digital representation of an image to a database that was stored with the missing children. So they compare both the images. If anything matches, that can be identified with the features. How they will compare is with the features, with the age, appearance of the victim in the images, face recognition, iris recognition, like that they can be easily identified with the victim. And what helped to solve this challenges by using a machine vision application. One famous machine database that was used is MemSQL. So MemSQL is a single store modern relational database for cloud, and it's a distributed relational SQL database management system that feature ANSI SQL support for speed in data transaction processing and query processing. It run in various Linux environments. So that MemSQL plays a major role in this challenge. So what is the role with the MemSQL is, actually this is a real-time data warehouse. So it fights against the online sexual abuse of children, and it helps to facilitate and process the match the images. So it uses some advanced image computations to build operational applications without using some disparate systems. So they use a thing called dot product, MemSQL dot product. That is a capability that enables the vector comparisons for feature vector comparisons for real-time image acquisition. So the feature vectors are all calculated for multiple images with a low computation workload, and then that gets compared with the stored images. So then if any matching occurs with the database, then that will be identified as a missing children. That is, if you can find out the proper children. So this is facilitated through a dot product algebraic operation, and the similarity scores also calculated with the new images, with the known images. So this is what plays a major role in that challenge. So MemSQL is a single store modern relational database that was used for cloud. So that is one important feature. And first, to apply that feature, what you have to do is first you have to train your deep learning system with the known data inputs, and then once the data analytics program is in place for a problem you need to solve, you can implement your machine vision technology in a highly performant and scalable way with the help of MemSQL. So features vectors are all calculated with the deep learning algorithm, and you can easily identify the problem. You easily solve the problem with the identification. So this is what the challenge, one important challenge that was happened with the machine vision and AI. So basic challenges that was basic overcoming. These are the challenges which we have defined now. One basic overcoming that particular challenges with the help of the machine vision is a self-driving cars. So self-driving cars that utilize machine vision with some sensors for controlling the functions, and it will also avoid the collisions. So it can pick up the humans with it pick up the things that humans will not, and because they can look at everything at once. So the advantages and the limitations are all taken into consideration for overcoming the challenge. So one important thing is the self-driving cars. So this is what the one image for the self-driving car. Okay, so far we have seen some challenges and the applications on that. So what is a survey that made on the AI-based machine vision? So actually, we are using some inspection method for differentiating the AI with the machine vision. So what are the main issues with your current visual inspections method? So the survey says that 56% of the people says that the incidents are happening because of the defective. Good part are made, they're marked as a defective part. False calls. So that is happening with 56%. 50% is our inability to deal with the complex surfaces or inspections, and 42% have the inability to deal with variations in what is being inspected. 41% is labor cost is very high, and it is very expensive, and maintenance cost. 13% of the expensive and maintenance cost is made as an issue with the current visual inspection system. And what are the key findings out of the survey? So the overall opinion of the effectiveness of AI in machine vision is, first key finding is the manual inspection is playing a major role. Still, so many automation sectors have come. Still, the manual inspection, 40% of saying the inspection is either completely or mostly manual. So this is what is happening still. And then the confidence levels of the businesses regarding to AI effectiveness is high with 26%. They are already using the AI for visual inspection, but still there is a lack in that. Scarcity of data, complexity of integrating AI with the existing infrastructure, this will also be a challenges. So the most businesses have their ownerships of AI projects either by developing an in-house or they're working with for a vendor. So the overall opinion of the effectiveness of AI is 15% is very high, 39% is not high, 28% is moderate, 4% is very low. It is not effective is 2%. And with the features AI and combination of machine vision features is don't know by the 12% of people. So this is what the effectiveness of AI with the machine vision. Altogether, what are the benefits of machine vision applications? So we have seen some machine vision system now. So what are the benefits? It has a good performance, quality in the inspection, increased productivity, flexibility, less machine downtime, and reduced setup time. It has a complete information and the process control. So the equipment cost is also low, production cost is low, inventory control, and reduced floor space. These are all the benefits of machine vision system. So before getting into the machine vision system, you will see how come it is related with the AI and machine vision.
Not all machine vision and artificial intelligence are created equal. So how do you tell which solution is best? We know what it takes for these technologies to accurately surface patterns and identify risk. Now we'll see how Lytx proactively detects risky driving with high precision to serve up opportunities for coaching that inform without overwhelming. At Lytx, we combine video telematics with machine vision, artificial intelligence, and driving data to help solve our industry's most critical problems, like distracted driving. We tap into over 100 billion miles of driving data that we've collected over the years. But why is this so important? And why should you care? Because high-quality, validated data is the best way to train custom artificial intelligence to deliver the most accurate results. What sets our data apart? For starters, our unmatched volume of high-quality data gives us a more complete view of true risk. Then there's variety. Diverse information helps separate anomalies from confirmed patterns across a wide range of driving scenarios. Another key element is the velocity, the speed at which we capture data. Collecting lots of data quickly helps us update and improve our artificial intelligence technology. So it's always learning, refining, and getting better. But all this input doesn't matter if it's delivering useless information. And that's why our professional analysts work 24/7 to meticulously label high volumes of data. What does this mean for your fleet? Value. Lytx cuts through the noise to deliver moments that represent true risk throughout your driver's day. This lets you focus on coachable moments that actually matter and make a difference, keeping your drivers and fleet protected and your business running smoothly.
Hello everyone, I'm Harpreet Singh, welcoming you to the Future of Work Pioneers podcast.
AI fast-tracks effective data-to-decision-based smart manufacturing. Acquired production images are a common critical data type, benefiting particularly from AI analytics. The capture, processing, and management process does, however, present numerous challenges, making it costly, complicated, and time-consuming to implement. A typical system may comprise cameras connected to a frame grabber module in a host computer, with images acquired on the line and processed by specific vision software. Processing and management of the necessarily massive amount of captured data from machine learning requires a VPU-GPU integrated vision solution or a new heterogeneous platform. AD-Link's AI plug-and-play vision system provides a fast-to-market solution with minimal investment requirement on the original platform. With plug-and-play capability and no changes necessary to other components, AI-enabled vision function is up and running in a surprisingly short time. Their alliance with leading AI brands and certifications allows AD-Link to provide native support for AI-enabled solutions, delivering the most advanced technology, shortest time to market, and maximum reliability, while proven industrial-grade AI device construction delivers rugged, reliable, and highly integrated performance. With AD-Link's leading position in the edge computing field, our cloud solution package provides fast and easy connection of AI solutions to leading cloud services, realizing your data to decision to achieve real AIoT. AD-Link's more than 20 years experience in industrial automation and machine vision means we know our customers and how to best meet their needs. AD-Link, leading edge computing.
What will the manufacturing of tomorrow look like? Industrial parts are becoming smaller. Products get to market with less waste, faster, and on time. Even the most manual processes are turning towards automation. Innovations in machine vision, deep learning, and robotics are revolutionizing production lines and supply chains. Our machines now produce vast amounts of big data accessible via the cloud. As machines and the information they produce become linked, new cyber-physical systems will spark a modern-day industrial revolution. This is Industry 4.0. In Industry 4.0, smart machines learn from their environments and take corrective actions to optimize production. These machines work independently of a central controller, collaborating and communicating with other devices. Industry 4.0 factories produce new organizational intelligence, which spreads across facilities and is accessible anywhere. The result? Nothing short of total transformation of production lines and business performance. Machine vision will be at the heart of this new manufacturing paradigm. At Cognex, we are already offering Industry 4.0 ready solutions to help manufacturers innovate for the future. From the very first networked vision system, Cognex products have been able to communicate with other devices on the line and transmit manufacturing data. These with a factory's networked devices for data collection across plants and global networks, and insight into operations and performance improvement. Sensors guide and communicate with collaborative robots, which work safely alongside humans. Real-time monitoring capabilities anticipate and accommodate changes and adjust based on incoming data.
So coming back to the presentation, the machine vision system altogether is it's a technology that allows a computing device to inspect, evaluate, and identify a still or a moving images. So it is a field in computer vision. So it will be very similar to the surveillance cameras. So it will automatically capture the images, evaluation, and the processing capabilities. So AI is used in this machine vision system for continuous improvement in recognizing some applications. So it deploys in a scenario in which the vision system are used for object recognition. So incorrect predictions can be identified easily and it can be associated with the recorded data, so that you will be having an improvement on the vision. The system itself will get improved itself by continuously learning its mistakes. So this is what the machine vision system is. And the types of the machine vision system is 1D vision, 2D vision, and 3D vision. So 1D vision, it analyzes signal one line at a time. They are commonly detecting and classifying the defects on the products like metals, plastics, paper, and the sheets. 2D vision is it's a system that captures an image of an object using a two-dimensional map that can be expressed as a X and Y coordinates. 3D vision, here the machine vision system, it includes multiple cameras, one or more laser displacement sensors, and that will guide, it will provide the robot with the information about the part orientation. So these are the types of machine vision systems. And use of AI in vision applications is most important thing is the industrial Internet of Things. So that is what the upcoming thing. So it refers to the interconnected sensors, instruments, and other devices and networked together with computers. Industrial applications, including manufacturing and energy management, will also be managed by the IIoT. So that is what one basic application. And ability to recognize some objects, as well as finding out the defects and to improve the accuracy of the vision system. And the third usage is for inspecting the machine application with the applications accurately, translating them into a productivity and profitability in nature. So these are the use of AI in machine vision applications. And these are all the applications with the goals. AI machine vision helps to predict some of the goals, specific goals here. So the goals here are the higher quality. So higher quality in case of inspecting, measuring, and assembly verifications, and production flexibility in case of the prior operation, and less machine downtime So you can change the program, changeovers can be programmed in advance, and reducing capital cost, adding some vision to the machine so that it will improve the performance, and the production cost can be lower. So a vision system can be detecting the flaws early in the process so that the production cost can be lower, and inventory control and the reduced floor space. Scrap rate reduction is manufacturing process means more than making up cuts efficiently, it requires using a right tool for the job, right tool for the right job. So that we can maximize the efficiency. So that is these are all the goals with related to the applications, and these are the related searches that was found in the recent years. Research on the intelligent recognition of trained image based on the machine vision. So the images are collected and it was merged based on the wavelet transforms, and the fusion of the results was identified, and it was by using a major encoding technique, new technique of AI, this get processed. So that is what the first research is. And the next research is a pattern design of the knit and the pearl based on CAD system of automatic knitting machine based on the computer vision integration. So by using the CAD system, automatic knitting machine can be made with the help of the AI technique. Machine vision technologies are combined to make a automatic analysis on the CAD system. So that is what the second thing. So that the effectiveness of the results will be improved by using this integration. So machine vision and the computer vision are integrated so that effectiveness can be improved. And next thing is machine vision based localization of the intelligent vehicle. So this is another research paper. So it was aiming at implementing a lane recognition and determining the host vehicle's parameter, positions, and direction accurately, realizing the lane departure warning, and practical applications by using some algorithms has been proposed in this. And half transformation was used for as an algorithm for lane parameters. And the experiments, it was indicated with a good adaptive ability, and better roadway structure was eliminated with a safety system in the machine vision, with the help of the machine vision. So these are some of the researches, references for machine vision with the AI. So thank you for patiently listening. My sincere thanks to HOD ma'am of EC Department, Panimalar Institute of Technology, and Professor Arun sir for giving me this opportunity to deliver the session. Hope all the participants gain some knowledge on machine vision in AI. Thank you, participants, and the team for listening. Thank you. Any queries?
So participants, now unmute yourself, clarify your doubts. Ma'am?
Yes.
In what basis we choose a normalization technique, ma'am?
Normalization technique. Okay, here. Okay, so here machine vision is used here. So machine vision in AI is used here. So how come the normalization technique used in this is the database here organized. The database which we are maintaining is organized. Since we are using many techniques, AI techniques, the types of normalization and the database. One specific example which we have seen is a MEM-SQL. So MEM-SQL, that example we have seen. So the organizing the data in the database and the duplication removal in the databases. So this can be redundant data's utilization can be avoided. So by using this normalization techniques. So in that case, the AI techniques can be any of the AI techniques can be used for normalization. So because normalization is a process of organizing data into a related table. So redundancy has to be reduced. Integrity has to be improved. So the performances have to be improved. So that can be done with the relationships of informations in the table. So that can be done easily with the help of the techniques available. So that way it can be used because basic normalization will be sought out by the available techniques, AI techniques.
Okay.
So that way that can be improved. So machine vision and AI also have the because machine vision is applied with the AI technique. So the database can solve the machine vision problems with the normalization.
Okay. Thank you, ma'am. Thank you, ma'am.
Okay, thank you.
So any other question? So I'd like to extend special thanks to session speaker Dr. Venkata ma'am, who shared the knowledge regarding vision effects in AA and its challenges. So it was really informative and inspiring us, ma'am. Thank you, ma'am.
Thank you. Thank you so much.
And also, I thank all the participants for lending your time today. The participants, the feedback link posted in the chat box, please do fill it before you leave the meeting.
Thank you, participants. Being in the Sunday, you have patiently listened to the lecture. So thank you so much for patient listening. Thank you, Arun sir, for organizing such a meeting. Thank you.
So next session will be informed later in WhatsApp group.
Thank you, ma'am. Thank you for your valuable presence. Irrespective of the Sunday, you kindly accepted our invitation to deliver the talk. Thank you once again for being part of our Panimalar Institute of Technology, STTP.